couple more. Problem number 4, this one's going to be quick. It says f of x equals 4 to the negative x power. Remember that another way of thinking about this function is f of x equals 1/4 all to the x power. It should be a similar sort of graph to problem number 3, actually, where we tend to 0 very quickly as we go to the right. Of course, what I just drew was sloppy and inexact. It's just to give you a sample. So let's erase that and actually do this for real with an input-output table. So x and y. I'm just going to input a couple values. I don't need many to get a nice graph. 0, 1, 2, -1, -2. That should be enough. 0, 4 to the 0 is 1. 1, 4 to the -1 is 1/4. Oh man, this thing is shrinking quickly. With an input of 2, I should be outputting 1/16. With an input of -1, I should be outputting, let's see, that's 4 to the -1. Oh, it's just 4. And then if I'm inputting -2, that's 4 to the -2, 16. That's already off the graph. Okay, I can get my picture really quickly now. So -2, 16 is off the charts. -1, 4 is on the graph. 0, 1, 1, 1/4. Okay, here it is. There's my graph. I still have my asymptote, my horizontal asymptote, that is. My horizontal asymptote at y equals 0. There's no vertical asymptote. This growth is unbounded. If you look towards the left direction, this thing can go, it continues to go out kind of in a northwest direction. It's just going north a lot faster than it's going west, but there's no vertical asymptote. There's nothing to bound how far this left part of the branch is going. Okay, then that takes care of graphing, and what I'd like to do next is take us to solving equations. Let me just switch ink colors here. I've still got red. Hold on a second. Sorry about this, guys. Sometimes the ink doesn't want to change colors if I've put my pen on a graph. Okay, there we go. We've got purple back. We've got a couple equations to solve, and we'll kind of go through that, and then you guys are going to be done for the day, and hopefully you guys enjoy your snow day and you're being safe. The main idea for solving these equations, the main idea for all of these equations is to get the same base, and then you want to equate your exponents. We're going to get the same base on both sides of the equation, and then we're going to equate the exponents. We're going to set the exponents equal to each other and solve for the variable. The example for that for part A would be to rewrite 9 to the x as 3 squared to the x equals 3. Okay, so we rewrote 9 to the x as 3 squared to the x equals 3. Well, what's the whole point of that? Well, power of a power, I know the power of a power property, I know that the 2 and the x are to be multiplied. So I have 3 to the 2x equals 3 to some power. What power is it going to be? I wish I could call on someone, but just remember it's the first power. Now we're going to set the exponents equal. If the bases are the same on both sides of the equation, you could set the exponents equal to each other. So 2x equals 1, so x equals 1/2. Now you kind of want to mentally check your work and make sure that it makes sense, but 9 to the 1/2, that equals 3. That should work out just fine. Part B, this is kind of strange. It's a different sort of problem because it doesn't seem like we're going to be able to get the same base on both sides of the equation. Actually, we can. If you factor the number 8, we know that it factors as 2 cubed. So 2 cubed to the x equals 1/2. And in fact, 1/2, I can also rewrite 1/2. I could think of 1/2 as 2 to some power. Once again, if I were in class today, I would ask people what that is, but it's 2 to the negative first. So I've got 2 to the 3x equals 2 to the negative first. So look what I've done, guys. What I did was I rewrote 8 as 2 cubed, and then I rewrote 1/2 as 2 to the negative first. The benefit of doing that is now I can set the exponents equal to each other. So 3x equals -1. And so x equals -1/3. Once again, you kind of want to do a little mental check and make sure that that makes sense, but I know that 8 to the -1/3 is going to be 1/2, so that's just fine. C, same exact procedure, so I'm going to go through that a little bit faster this time. I'm going to rewrite 25 as 5 squared. 5 squared to the 3x equals 5 to the x minus 4. Now remember to multiply the powers together. So I've got 5 to the 6x equals 5 to the x minus 4. Same thing over again. I'm going to take those exponents and I'm going to set them equal to each other. So I've got 6x equals x minus 4. So therefore 5x equals -4. X equals -4/5. And there it is. Now I could plug x back into both sides of that equation to make sure it works. It actually does work, so I'm not going to show the work of that. And then let's do D, E, and F, and then you guys will be free for the day. Well, hopefully. I don't know if other teachers are doing web lessons, but hopefully you don't have too many of these today. Okay, let's take a look at D. For D, it's slightly different, right? I've got 1/16 equals x to the -4th. Well, I'm going to rewrite this as 1 over 2 to the 4th equals 1 over x to the 4th. And then you could really quickly see what your answer is going to be. 1 over 2 to the 4th equals x to the 4th. So it must be the case that 2 equals x. That's one way of solving it. There's going to be other ways to solve that equation as we work through this class and as we try other sorts of examples. But for now, I think that's fine. Okay, part E. I tried to throw a curveball at you guys. That one looks really daunting and really difficult. And especially if you guys were in class today, this would be a challenging one that you'd be working through with your groups and kind of struggling through and asking questions and discussing with each other. But since we're not in class, what I'm going to do is I'm just going to tell you how to do this. I am going to take the cube root of 4 and I'm going to rewrite that in a clever way. I'm going to say that the cube root of 4 could be rewritten as, well, let's see, 4 is 2 squared. And the cube root, that's just the 1/3 power. So what I've done is I've rewritten the cube root of 4 as 2 squared raised to the 1/3 power. And then that's all to the -x equals, and I guess I could do a similar sort of thing on the right side of the equation. If you look at this 1/2, I could probably write that 1/2 as 2 to the -1st. Basically what I'm doing here, folks, is I'm succeeding in this goal of getting the same base on both sides of the equation. If the bases are the same on both sides of the equation, you could set the exponents equal to each other. So that's really what I'm doing. Okay, so I guess that's 2 to the, let's see, 2 times 1/3 times -x. Let me highlight it again. I don't know if I'm overdoing the highlighter, but 2 times 1/3 times -x. That's going to give me -2x over 3 equals, and then on the right side, I just need to make sure that I'm multiplying these exponents together. So -1 times x, -1 times -3, that's going to be 2 to the 3 minus x. And then at that point, it's acceptable to set my exponents equal to each other. The reason I'm allowed to set those exponents equal to each other is because the bases are the same. So I have negative 2x over 3 equals 3 minus x. Now we can go ahead and solve this equation. So I have negative 2x equals 9 minus 3x. I multiply everything by 3 is what I did there. And then let's see, let's add 3x to both sides. So looks like we just have x equals 9. And there it is. I would say this is a really powerful equation solving technique, getting the same base on both sides. Because if you look at this original equation, it's a mess, right? You've got a cube root of 4, you've got a 1/2 to the x minus 3, there's weird exponents going on, different bases, you know, it seems like it's really difficult to solve if you first glance at it. But if you just make sure that you do this equating the bases, equating the exponents after having the same base thing, then it's a simple equation to solve. You're just solving negative 2x over 3 equals 3 minus x, which you guys are all able to do very easily. Okay, and then part F, there are multiple approaches that I can do to part F. Probably the easiest one to do is to say x to the 3/2 equals 2 to the 3rd power. Okay, well then it seems like it would be a clever idea to take the cube root of both sides. So if I take the cube root of both sides, cube root, I get x to the 1/2 power is equal to 2. Another way to think about that is root x equals 2. So therefore, x is equal to 4. There's other ways you can solve that. There's other techniques we'll talk about when we get back to class and we're all together again. But I think that's a nice way to do it. What you need to do is you need to be able to show willingness to take a number like 8 and write it in exponential form. You'll notice that's the kind of the common thread with all these equations. It's taking numbers and rewriting them into a simpler exponential form, and then go on from there. Okay, guys, I hope this was helpful going through this worksheet for you, and I think that should have you well prepared for doing the homework that is going to be due on Thursday. The only other thing I'm going to mention before calling it a day is I want to remind you guys that it's important to check the website on Thursday if we're not here on Thursday. There's always the possibility that there'd be another snow day. I don't expect that to happen, but it could happen. And if it does, just make sure to check the website Thursday, and we'll do the same thing again with a web lesson and other materials posted to the web that you'll need to take a look at. Okay, enjoy your snow day, and I will see you guys soon. Bye-bye.